Okay, so today we're going to be talking about some of the properties of logarithms. And I think the big thing is, you know, uh, that you can work with logarithms and change their form to help you find an answer. So on these first three questions, basically, if you're like, what is x? Well, you would change from logarithmic form to exponential form and kind of look at the problem and say, hey, what do I notice? Okay, and so if you did 4 to the 5 halves, you're going to get x. You're like, okay, well, then do 4 to the 5 halves and you'll know what x is. You have to square root it and then bring it to the 5th power, and so you're going to get x is 32. Now, one thing I'm going to teach you right now is this. If you get a value for x, you have to make sure that that does not make the argument, okay, the value of the logarithm right here to be negative. Okay, 32 doesn't make the argument negative, so we're good. Okay, so you're not allowed to have an x that causes the argument to be negative. So if you did get one that causes the argument to be negative, well, then you would say it's extraneous. So 27 to the 2/3 gives you x. Okay, great. We'll take 27 to the 2/3, square it, and take the cube root of it. That would give us 9. The cube root of 27 is 3. 3 squared is 9. Okay, and so same with this. 16 to the 3 halves gives you x. Square root and cube 16. Square root of 16 is 4. 4 cubed is 64. Now, on none of these does this cause our argument to be negative, so those are valid solutions. So, that's something that you can do if you're solving an equation, okay? And, on your homework, you may see some questions where, it'd be like log base 3 of x plus 1 is equal to, 4. And you'd be like, okay, 3 to the 4th equals x plus 1. Take 3 to the 4th power, that's 81, and then subtract 1, x is equal to 80. Okay, so we could take it up a big kid step and be like, hey, can you bring this 3 to the 4th power and then evaluate it to say what would x be? Okay, and so changing forms is an option as well. So the next thing I want to show you guys would be, it's called the property of equality. Okay, and what they're reiterating in this box is we want the base to be not 1 and we want it not to be negative. But this is the deal. If you look at this, you can say, hey, if I've got log base 5 equals log base 5 of 2 arguments, if this is a true equation, and if that's all I have is I got a log on each side, well, then that means that these arguments have to be equal to each other. You see that? So if I just have the log of the same base on each side, I can set their arguments equal to each other and solve the resulting equation. And so that's what we'll do. We'll say, okay, well, if 2x squared minus 6 equals 4x, well, then we can solve the equation to figure out what x should be. Well, that's a quadratic. Thank you for sharing. Just kidding. So we're going to haul everything to one side, bring it to the side where there's an x squared. That's positive. And so you get 2x squared, bring the 4x by subtracting it, and then minus 6 equals 0. I am going to divide each term by 2 because it's equal to 0, so I can divide each term by 2 without hurting anybody's feelings. And then I'm going to factor this, and I'm going to get x minus 3 and x plus 1. I get x equals 3 and x equals negative 1. And now remember, those might be valid solutions, but you've got to make sure that neither argument becomes negative in the process. If you look on the left side and you do 2 times 3 squared, that's 9 times 2 is 18 minus 6. That's going to stay positive. And then 4 times 3 is 12. That's going to be fine as well. We're not checking if it's true. We're just having to make sure that neither argument goes negative in the process. Now, if you look at the second one, on the left, it stays positive, but on the right, 4 times negative 1 makes this argument to be negative 4. So we're going to throw away this and say she's extraneous. We're not going to use that one. So always find the solutions. Sometimes, the answer will be both of them, okay? And sometimes it will be just using one of them. And so be careful, to do this as you go. The next one, okay, if you've got just one log on each side, switching forms doesn't make sense, but the property of equality actually does, okay? And so what we're going to do is we're going to set these arguments equal to each other and solve it. And of course, it's going to be a quadratic. Now, I like my x squareds to be positive, so I'm going to move everything to the left side, which makes this a positive 2x squared when you add it. a minus 5x and a minus 3 equals 0. And we've got to factor them up. We're going to get 2x and x. Let's see, we're going to do a 3, a negative 3, and a positive 1. And if you set them each equal to 0, you get negative 1/2, and you get x equals 3. Now you would think, throw away the negative 1/2. However, think about this. Look back up at the arguments. We have a lot of negatives running around slapping themselves screaming, okay? If you try 3 on the left side, that's going to give us a negative 15 as our argument. So actually the positive number is the one we throw away. If you do 5 times negative 1/2, it'll give you a positive value. If you do the one on the right, half squares 1/4 times negative 2, and then you add 3, that will also be positive. So the truth is that the negative answer is actually the winner, on that problem. Okay, so that will be the answer. Okay, so another thing we're going to talk about would be, remember we talked about why we have logarithms is because in the world of exponents, multiplication becomes addition, and in the world of exponents, for the exponents, and in the world of exponents, when you're dividing, you subtract the exponent. So here is what we're talking about. It's kind of weird. If you've got two logs that are added together, you could make them to be the log of the product of those arguments. And so if you've got the log base 8 of 5, or 5 of 8, log base 5 of 4, you could write it as the log base 5 of 32. Okay, so we're talking about how could you use those properties. Okay, there's lots of ways we're going to use them, but that's one of the rules, and we're going to practice it in one direction today. Okay, we're going to build on it another day. The other one that we're going to talk about, there's three main properties. If you're subtracting two logarithms, the second property would be you can write them as the quotient of those two arguments. It's always the first one over the second one. Okay, so log base b of m over n, it would be equivalent to that. And so I show it with numbers as well. So it's kind of weird. Be like, if you're subtracting logs, how would you do it? You can combine them to be the log of a single log, a single log by writing the arguments as a quotient. And it has to do with logarithms or exponents. The last one is going to be if you have a logarithm to a power, you remember you multiply. Well, you can bop this to the front, the exponent to the front of it right here, so it becomes a product of that logarithm. So those are three things you can do. We're going to practice these abstractly and be like, okay, can we do this a little bit? And we need to keep practicing this. This is a skill that we're going to work on. But how we're going to do that today is going to be this. We're going to say, I want you to do this, and I want you to use those properties to help us say, can I express the log base 3 of 45 using the log base 3 of 5 and the log base 3 of 2? Okay, so you can't use. So the question is, how can you represent it in terms of those two things? And the answer is you can't. So let's also think what other things would be appropriate to use, okay? Another appropriate thing would be log base 3 of 3 equals 1, okay? Another one would be log base 3 of 9 equals 2. Okay, so those are things that they don't tell us the answers to, but we're smart humans. We know those two values. Okay, so let's think about, using one of those two options. Okay, so, we learned on the previous side that if you've got log base 3 of something, okay, you can write it, this is 9 times 5. Right? 9 times 5 is 45. Well, okay. Well, then how can you write this as two different logarithms? Well, you could do log base 3 of 9 plus log base 3 of 5. What? Okay. So, because if you've got two logs added, you can write it as the product of those logarithms. Well, this is 2. Log base 3 of 5, they gave it to us as 1.465. If you plus those two values together, you're going to get 3.465. So that's going to be our answer here. Okay, so it's a little bit of a trick question. Okay, so let's think about the next one. Log base 3 of 6. Well, it's not 2. Okay, 3 squared is not 6. Okay, so we're like, we can't do that. But what can we do? Okay, we can write this as the log base 3 of 3 times 2. Okay, because 3 times 2 is 6. Well, that could be written as log base 3 of 3 plus log base 3 of 2. Okay, we're learning the properties of logarithms by thinking about what could be true. So this is 1, and then they give us log base 3 of 2 is 0.631. Okay, so the answer is 1.631. Okay, it's a little bit of a challenge. Okay, the next one, okay, log base 3 of 30. Okay, how can we express that as something cute? Like, I don't know. Well, we do know log base 3 of 5, okay? 5 times 6 is 30. Well, we don't have 6, but we do know 2 and 3. Okay, now we're just taking it up 2 money notches at this point. Log base 3 of 5 plus log base 3 of 2 plus log base 3 of 3. So 5 is 1.465. Log base 3 of 2 is going to be 0.631. And then log base 3 of 3 is 1. If you add these together, yes, use a calculator, you get 3.096. Okay, so we're saying, can we express this using the given things plus a couple cute ones that we know to make this work? Okay, so the next one would be log base 3 of 9/5. Well, remember, in the logarithmic world, you can express this as the subtraction of 2 logs. So we could do log base 3 of 9 minus log base 3 of 5. Okay, you do the numerator is the first one that you subtract. And so this would be 2 minus, and log base 3 of 5 is going to be 1.465. If you minus those, you're going to get 0.535. Okay, so we're expressing using those properties. It's a little tricky. Log base 3 of 40. Well, 8 times 5 is 40. And so we're like, well, how do you get 8 out of this situation? Okay, well, let's try it. Log base 3 of 8 times 5, right? Well, 8 is too cute. You're like, okay, this is crazy. It is. Okay, too cute. So here's where we'll use that last property where it's, again, it's a little tricky. So you do log base 3 of 5 plus log base 3 of 2 cubed. And so again, if we're trying not to use a calculator except for the basic functions, log base 3 of 5, they give us as 1.465. And then one thing is, because logarithms are exponents, you can bring this to the front as a 3 times the log base 3 of 2, which is going to be point. So if you take 1.465 plus 3 times 0.0631, you're going to get your answer. And your answer is going to be, 3.358. Now that's a bit of a stretch. And I feel like we do need to practice a little bit with that, bringing it to the front. And I think that's something that we will do on Monday or on our next day that we work together. The last one would be, can you read this word problem? Can you plug in what you know? Can you figure out what the answer would be? Okay. The loudness is how much, how much you hear it. Okay. And so they say the loudness in decibels of how loud something is using this format where R is the relative intensity of the sound. And say, okay, how many members could sing while maintaining a sound, what does that word say? It says a safe level of sound, about 80 decibels. Okay, so one person sings at 10 to the 6 intensity when they're singing. How many people could sing at the same relative intensity to achieve that decibel? Okay, so our goal is to keep it to be 80. And so we've got 10 and then log base 10. Okay, so then we put in here the number of, so it'd be 10 to the 6 times n. Okay, so to solve this, we're going to divide both sides by 10. Okay, so get rid of this coefficient. You get 8 is equal to log base 10 of 10 to the 6 times n. So then the question is, how do you figure this out? Well, I think the big thing would be switch forms. Okay, 10 to the 8th is equal to 10 to the 6th times n. Well, divide both sides by 10 to the 6th. Divide by 10 to the 6th. And then you're going to get n is equal to that quotient. Well, you're dividing. You're going to get, you subtract the x1, so you get 10 squared is equal to n. So n equals 100. So there's 100 people who could sing in this choir. All right, well, thank you and have a good day.